Okay, let me first define the most frequently used terms in digital image processing and some of the basic concepts and terminology related to this topic. First of all, what is an image? An image is a visual representation of an object, a person, or a scene produced by an optical device such as a mirror, a lens, or a camera. This representation is two-dimensional. However, it's corresponds to one of the infinity projections of a real-world three-dimensional object or scene. What is a digital image? A digital image is a representation of a two-dimensional image using a finite number of points, usually referred as a picture elements or pixels or pels. Each pixel is represented by one or more numerical values. For grayscale or monochrome images, a single value representing the intensity of the pixel, and it is usually between 0 to 255. And for color images, three values corresponding to the amount of the red, green, and blue are usually required. What is digital image processing? Digital image processing can be defined as the science of modifying digital images by means of a digital computer. What is the scope of image processing? There are three levels of image processing operations: low level, mid level, and high level. Low level image processing operations consist of primitive operations such as noise reduction, contrast enhancement, and etc., where both the input and output. Low-level image processing operations include primitive operations such as noise reduction and contrast enhancement, where both the input and output of these operations are images. In the mid-level operations, we try to extract some attributes such as age, contours, regions, and etc. from the images. And in the high-level operation, we try to analysis and interpretation of the content of the images. Image processing is a multidisciplinary field with contribution from different branches of science such as mathematics, physics, optical and electrical engineering. Also, it overlaps other areas such as pattern recognition, machine learning, artificial intelligence, and human vision research. Let me give you some example about image processing operations. In this figure, you can see an example of low-level digital image processing operation known as sharpening. This is a technique by which the edge and fine details of an image are enhanced for human viewing. In the left side, you can see the original image, and in the right side, you can see the after sharpening image. So both of the input-output of the low-level operations are images. Let me give you another example of low-level operation, noise removal. As you can see in the left side, we have a noisy image. So image processing filters can be used to reduce the amount of the noise in an image before processing in any further. Of course, depending on the type of the noise, different noise removal techniques can be used, and we will learn them in this course. Here you can see another example of low-level operation known as deblurring. An image may appear blurred for many reasons, ranging from improper focusing of the lens to an insufficient shutter speed for a fast-moving object. We will learn some deblurring algorithms in this course in the future. In the left side, you can see the original blurry image, and after removing the motion blur, you can see the output. Edge extraction can be one good example of mid-level operation. As you can see in this image, in the left side we have original image, some rise over a surface, and in the right side, after extracting its most relevant edges, we have the boundaries of each of the rise. Extracting edges from an image is a fundamental pre-processing step used to separate objects from one another before identifying their contents. We will discuss different edge detection algorithms and techniques in this course. Binarization is another image processing operation. In many image analysis applications, it is often necessary to reduce the number of gray levels in a monochrome image to simplify and speed up its interpretation. So reducing a grayscale image to only 2 levels of gray, black or white, is usually referred to as binarization. As you can see in the left side, you can see the original grayscale image includes some coins, and in the right side the intensity levels are only black or white. So we convert the grayscale into the black and white version. The next operation is blurring. Sometimes it's necessary to blur an object in order to minimize the importance of texture and fine detail in a scene. For example, in case where objects can be better recognized by their shape, it is better to perform blurring as a pre-processing. So in this image, you can see in the left side the original image, and in the right side, after blurring, we remove unnecessary details. We only keep the shape of the objects. Contrast enhancement is another image processing in order to improve an image for human viewing, as well as making other image processing tasks such as image extraction easier. It is often necessary to enhance the contrast of an image. Contrast enhancement techniques using transformation functions and histogram processing. We will discuss these algorithms in detail in future. So as you can see, the left side is a low contrast image of a scene, and in the right side, after performing the histogram equalization, we improve the contrast of the image. Object segmentation and labeling. The task of segmentation and labeling objects within a scene is a prerequisite for most object recognition and classification systems. Once the relevant objects have been segmented and labeled, the relevant features can be extracted and used to classify, compare, cluster, or recognize the object in the question. So as you can see, in the right side of this image, the different type of the coins are recognized. So object segmentation and labeling is a high-level operation.